superclass, subclass, this kind of association. So now we talk about mapping of these, mapping to relation of relational model. Say, if we consider that one, say person. Say student, faculty. Now, whenever we are going for this mapping, say it may be single relation or multiple relation. If we go for, say, mapping into multiple relations, then one case may be a relation for superclass and one relation for each of the subclasses. Right? So basically then we have a person relation, student relation, faculty relation. Then in the subclasses it will have copy the primary key of superclass, that will be foreign key here, and also it is a candidate key or maybe primary key. In general, we can think of plus the additional attributes of the student. The student may have some date of admission, etc., etc., date of joining, say highest degree, etc. Person may have some person ID, name, date of birth, etc. So superclass will have its own attribute. It will have its own attribute plus the primary key of this one, so that we can maintain the relation. Similarly, this one also. Now see, if we go for a design, depending on the constraint, how good or bad it is. If it is so that this is disjoint, or say this is overlap, person may be student, may be faculty, that is both. A person may be both. If it is like this, so if it is overlap, and answer may be the completeness constraint. Say if it is partial, superclass is taking, but participating in the association partially. Say no issue. Model is good enough. See, as this is partial, some of them may not be neither student nor faculty. So that will remain only in the person. And again, if it is overlap, say the person is both a student and a faculty, say PhD student and the faculty both. Then also the common information we are keeping only once, because for that particular person we will have an entry into student or only the additional attributes. We will have an entry into the faculty or with the additional attributes. So no redundancy. For this situation, this model is good. Rather, this will be the best situation. Now suppose, if it is total, every person must belong to at least one of the subclasses. If it is the total participation, then also no problem, because we are not repeating the things. We are not repeating the things. The common part will be stored only once. So be it total, be it partial, this will be working fine. If it is disjoint, then also no issue. If it is disjoint, say if it is disjoint, total or partial, then also no issue. So basically, this model that will be considering one relation for the superclass and separate relation for the subclasses. These can work for all the constants, be it overlap or disjoint, and be it total or partial. So in all cases, we can go for this model. Now, if we take another model, again multiple relation, will not no relation for superclass. No separate relation for superclass. Then for each subclass, consider a relation. So as per this model, model A will have a person relation, will have a student relation, will have faculty relation, will have your person ID and other attributes. Here we will be having person ID and the additional attributes. Person ID refers to this one. Here also we will be having person ID and its additional attributes. This is again referring to this. Now in this case, we are saying that okay, we will be having only the relation for the subclasses. Relation for the similarly for another subclass. What will be the attribute of the subclass relation? Attribute will be attributes of superclass. So all the superclass attributes we have to consider here. Union its own attributes. So superclass attributes plus own attributes. The superclass primary key, that will become the primary key here. So it will be like this. Now see, if it is total participation, if it is total participation, okay, I am not losing any information. Every person will belong to at least one of the subclasses. That is the meaning of the total participation. So I am not losing any personal information. But if it is partial participation, a person is not part of any student or faculty, then where to store? So lost, cannot store. So if it is a partial participation, this model cannot work. Right? Now if we think about, say, the other constants, if it is overlap, a person may be both. If it is not disjoint, overlap, it may be a student, maybe a faculty. Then the common information we are storing twice. So same information may have to be copied into number of subclasses. So it will lead to redundancy. That means wastage of space, possibility of inconsistency. Right? If it is disjoint, no problem. So basically, this model is suitable if it is disjoint and total. If the specialization is disjoint and if the participation or completeness constraint is total, then this model will be useful. Otherwise, this model either will be losing the information if it is partial, or there will be redundancy if it is overlap. So these are the two scenarios if we want to implement the superclass subclass relation using multiple relations of relational model. Now, if we think about implementation using a single relation. So, single relation based implementation. Say, then we have one relation attribute. It will have attributes of superclass and basically union of attributes of superclass and those of all subclasses. I cannot lose any attribute information. So single relation, if we have the attributes of all the attributes of the superclass and all the additional attributes of the subclasses, and a type field that will denote the type of subclass. So as there is a single type field, so here it can support disjoint specialization. It cannot be part of multiple subclasses. Right? Again, if we go for that, then so many repetitions, that thing will come up. Another is the minor variation of this one. This is just like the previous case, that one relation, the schema will have attribute of superclass, union attribute of all subclasses, union a number of type fields. We'll talk about this. Basically same as number of subclasses. As if, say, if there are 3 subclasses, type 1, type 2, type 3. So as if this is 1 means, okay, it belongs to type 1. 0 means it doesn't belong to that. So it can, so instead of this type field, we can say if there are n subclasses, then we may consider n bit flag. Say bit 0, bit 1, bit n minus 1 at any bit position. If we are having, say, bi equals to 1, means belongs to ith subclass. So that also we can go for implementation. So only difference is that we have the provisions. So if it is overlap, it will belong to multiple subclasses. So in multiple type 3 or in multiple bit position, we have this flag on. So it can support, this model can support overlap. Obviously, if it supports overlap, it can also support this joint. Only one field is having one. Others are not set. Right? So, but this one overlap, it cannot be supported. Here overlap, we can support. But see, this C and D models, rather if we look into these four models, A, B, C, D, they have their own pros and cons. So we have model A, model B, model C, model D. These two are having multiple relations. For these two models, we have the single relations. Here we have the relation for superclass plus subclass. Each of the subclass, here we have only the subclasses, not for superclass separately. Here we are having one relation. Now suppose say for a subclass instance, we also want to know corresponding superclass information. So here we have these, in this model, if we go for the example, person, student, faculty. Here we have only student and faculty. So if this is our requirement, say for a particular student, I want to also know the common information. He was a person, he is a person, and also a student. In student table, we are having this relation, it is having additional attributes. So what we have to do? For that, if we go by model A, we have to carry out a natural join or equal join with person ID of person equals to person ID of the student. We have to carry out this operation person dot person ID equals to student dot student ID. Sorry, student dot person ID. Then that will be meaningful join. So as per model A, if we follow model A, then we have to support this requirement, carry out equal join. If we think about B, see, here we have the common attributes, attribute of the superclass plus the additional attributes. So no equal join is required. Even for C and D also. In this case also, we have the superclass attributes along with the corresponding subclass attributes. So if we go for this model, there we have to go for equal join. Right? Now, suppose we want to know all superclass information. That means I want to know the person information. So model A, it will give us directly. It has a separate person, so I want to get the superclass information. So model A, we have a class corresponding to the, our relation corresponding to the superclass. So directly we can get those information. But see, if we think about this B, model B, there is no separate superclass relation. So superclass instances are divided into these two, student and faculty. If it is overlap, then we will commoners. Then what shall we do? We will have to go for outer union operation. But see, for C and D, it is already available, single relation. We have all the superclass informations also. So no outer union is required. Right? So see, for the model C and D, no equijoint required, no outer union required. But there are some problems of model C and D also. Say, a superclass instance. Say, subclasses are having number of attributes. A superclass instance may be a particular instance of the superclass may belong to low number of subclasses. See, if it is not total, then it may not belong to any of the subclasses. If it is disjoint, it will belong to only one subclass. If it is overlap, it may belong to multiple subclasses. It may not be that. If there are 5, 6 subclasses, it may belong to only 2 or 1 like that. Now, if the subclasses are having large number of attributes, then lots of null value in the attributes. The subclass attributes of which the instance is not part, then for those attributes we have to go for allow the null value. So that is a major problem of this C and D. If it is so that subclasses are having very less number of attributes or no attribute, say not a large number of subclasses and they are not having large number of attributes, then one can think of C or D, this model. Because it has the advantage, I don't require any equijoint, I don't require any outer union also. But this is important, that number of subclasses are not very large or at least, and they are not having, I can even ignore this one if the subclasses are having only 1 or 2, very less number or even no additional attributes. Then only we can think of these. Now see, again in these models also, say if it is a partial participation, then lots of null values will be there. So that's why this kind of constants are required. If the situation satisfies these things, then only we will think of the C and D. But see, this particular model A, although we may have to carry out some additional operation, but this is, it can support all the scenario. be it overlap, be it disjoint, be it total, be it partial. Otherwise, depending on those situations, everywhere we may face some problem. See, all will be working fine if it is disjoint and total. Then this is also good. Then I will not go for this thing, right? Except in one case, that here I have to go for outer union. So depending on the requirement, what we are going to do, what are the constants, we can select the suitable model in our application. So that is the way of mapping a superclass subclass into the relations of relational models. Specialization hierarchy and lattice. Just to know the terms. So suppose if this is the case, a person say if it is a hierarchy, a subclass can take part in superclass subclass association with only one superclass. So basically, a subclass can have one parent or one superclass. So basically, no multiple inheritance. So it's a tree kind of thing. So if we can have further say permanent faculty, contractual faculty. Now suppose if we have a category, a subclass like this, academic officer, which will be say a person say student, faculty, officer. So faculty may be yes or contractual or permanent. Now suppose we find that there are another subclass like say academic officers which have the features of both a permanent faculty and an officer. So it will have a superclass subclass relation like this and again with this one. Right? Now we will not say this is a specialization hierarchy, lattice. So in a lattice, a subclass can have multiple parents. But see, in every subclass, superclass specialization, there is only one superclass. So it is taking part in multiple superclass, subclass specialization. But for each of the superclass, subclass specialization, there is only one parent. So anyway, so this one is, we'll say, this is a shared relation. So in case of a lattice, we can find a shared relation. It is having multiple parents. So it's now no longer a tree. As if, I mean, we will not say this is a simple hierarchy. So this is the terminology for lattice. Now, we can have a different kind of situation. Say, owner of a property, that may be a bank, that may be a company, that may be some individual, say person. So see, this is also a specialization kind of relation. It is also having multiple these kind of things, but they are of different types. In this case, see, the officer, faculty, all were the person. They are of similar kind of entities basically. Here, see, one is the bank, another is the, or it may be, say, some finance organization, or bank, or insurance company like that. Or some industry, normal company, business house, say a person. Then see, this is a special type of, so this is a subclass. These are the superclasses. So it is having multiple superclasses, special type of superclass, subclass, association. Here also we have multiple superclasses for the subclass. But these superclasses, they have different, they are of different type of entities. maybe their keys are also different. Keys are also of different type. So try to understand the differences between the scenario. Not only that, say in this case, this academic officer, if we have an instance of academic officer, obviously it is a permanent faculty and also an officer. It will also belong to these and these. So here, in case of our these multiple inheritance, this for the shared subclass, for the shared class, not this one. Actually, this is known as union or category. So for this academic officer here, so for the shared class in our lattice, in this having multiple inheritance, instances of shared class will be the subset of intersection of its superclasses. Because academic officer, obviously it will belong to the permanent faculty, it will also belong to the officer. So here we can have which are the intersection of these two. Right? But here see, owner, it will have some finance organization, company, and person. Here these subclass, or we say this subclass is a special kind of, we say category. Category instances are subset of union of the instances in superclasses. So see, there is a fundamental difference. Here we can have the elements which are subset of these two, intersection of these. Here we will be having a subset from the union of these things. These we denote as union. And this subclass is known as category. So category is a subclass that has multiple superclasses, and those superclasses may be of different types. And the subset of the category instances, the instances in the category will be the subset of the union of its superclasses. Right? Now, a particular category instance, owner instance, what attributes it will have? Depending on whether it is financial organization or company or person, depending on that, different kinds of attributes it will have. So attribute is also sensitive. Here, if we look into the instance, it will inherit all the attributes of the superclasses, and it will go to all the predecessors, leading to the common one. Root. Mind it. Think about those virtual base class and all those things. Common ancestor. I have two paths. No, here we won't be having two copies. We won't be having two copies. If I consider that here I have all the superclass attributes, if I go for that kind of implementation, then it will have the attributes of faculty and officer. Additional attribute of the permanent, additional attribute of the officer. Then we can go here. Then we can go here. This thing is common. I have two paths, but I have only one version of the attributes. Okay. So if I go for that kind of implementation, here see a particular instance that may have attributes of these or these or these, depending on what type of element it is, what type of superclass element it is. So regarding the attributes, it's much more sensitive and selective, because we may have different types of entities with different types of attributes. Right? Now, one more thing is that they may not have a common primary key. They are of different types. So, in a category, superclasses of a category may not have a common primary key. So, a primary key in category has to be introduced. This is known as surrogate key. And it will be copied to all superclasses. See, in a hierarchy or lattice, we have a root kind of thing. So that primary key is applicable to all. Here we are not having like that. This is the union of all these things. It may have a different primary key, different primary key. So we introduce a common thing. That is the surrogate key. Maybe that owner ID. And in every superclasses, we copy this owner ID. We copy this owner ID and it will be referring to this. Just reverse scenario. So whenever we will be implementing a category, it will have its own attributes and the surrogate key, and say the owner may have, say, date of ownership, on which date I gain the ownership, and it will have some owner ID. So here also we are copying the owner ID. So the owner may have, the category may have the surrogate key and the additional attributes. And it will have the additional attributes and the surrogate key. So through the surrogate key we can correlate. Right? So that is the concept of union and category. So that's all for yard diagram and the corresponding mapping issues. Now, given a problem, given a system, so we have to study the system, interact with the, so there may be some manual system. If there is no computer system, at least there is some manual system. So we have the users of the current system may be the manual, maybe a computer system that will require upgradation. So capture the data requirement. Capture data requirement and their relation. So what are the different things with which the system will be working? Based on that, we will be forming the ER diagram. It may be an iterative process. It may not be so that at the very beginning, maybe that we are looking into a particular, focusing on a particular time. More and more we interact, we study the system, we can go for more detailing. We may find that there will be generalization, specialization. We may find out that to cater the need. What is the need? That is the data requirement. That means what query will have to support, what information I must be able to give to this system. So that will force me to impose the relationship that if my system is to know only to know the details of the students, only to know the details of the course, that's all, fine. Now if says that, we'll have to say which student is studying in which course, then we can identify that's a requirement, some report we'll have to generate. So I can find out we must have some relation. Then we may think about those following kind of thing and how we will be mapping this relation so that I can find out which student is studying in which course. Then it says that, okay, a course may consist of multiple subjects. Say course means program, say. Your UG, CSC, UG, ETC like this. Then I will find that, okay, I have to maintain a relationship like this. Otherwise, I cannot say this program will be covering which subjects. Now I can find that, okay, I want to know what the faculty is. Find it like this. Then I want to know which faculty can teach which subject. So I need this kind of relation. So see, as we go on studying the system, we can identify what are the data and what kind of query or report I have to generate. I can associate, I can incorporate the relationship. Then we may look into the mapping cardinalities or these weak entity type and all those things. Those so it's an iterative process. Once the ER diagram is formed, then we can go for the first level of design. When mapping the entity types and the relationship of ER diagram to the relation of relational model. In relational model, database is the collection of the relations. Okay, so that's the end of one thing. So next day we will start SQL and whatever we discuss in the next class, that is the part of the thing, that will be the syllabus of the first class test. And we decide about the classes date and modalities later.